Welcome to this ZENworks video demonstration. In this video, we will demonstrate how to create and assign a disk encryption policy and enable auditing for encryption events from the Getting Started page for encrypting devices. We'll also briefly explain how volume encryption works in ZENworks and the configurable options that you have with this policy. We've previously activated full disk encryption to enable the quick links that are provided in the Encrypt Fixed Disk Volumes section. To begin, we'll click the Create Policy link under Disk Encryption Policy. When clicking this link, the flow of the wizard for policy creation has steps 1 through 3 pre-selected. So we click Next or press Return until we come to step 4. After naming the policy, we start configuring the policy in step 5. We can encrypt all volumes or add one or more drive letters to encrypt specific volumes. We have a device with a D drive that we want to encrypt, so we're adding that drive letter. Generally, for the encryption settings, the default configuration is most often used. Note that changing the algorithm and key length are only applicable to devices using BIOS firmware. Devices using UEFI firmware always use AES with a 256 key length. The encryption lockdown option prevents volume decryption. If this option is enabled, device decryption can only be done locally at the device by using an administrator password. We'll leave the default configuration for emergency recovery. ERI files will still be generated in case the need for recovery occurs. The FDE admin password is required to complete the policy, so we'll add a password here. A reboot is required to initiate disk encryption, so we'll leave the default setting to force a reboot, but we'll notify the user with a predefined message that the action is queued up. We'll leave the check disk option in place and move to the Preboot Authentication configuration, or PBA. PBA adds another level of security to the encryption process by requiring user authentication before the device boots up. For this demonstration, we want this extra layer of security, so we're enabling Preboot Authentication. If you're using PBA, you have to add at least one means of authentication. We're enabling user ID and password. Either type of authentication requires additional settings to be configured for that selection to complete the policy. If you enable both types of authentication, you can choose which one you want for the default method. We also want to activate single sign-on in this policy, and then user capturing in the authentication settings. With user capturing, the credentials for the first user to log in at each device will be automatically added to the device's PBA to enable subsequent logins. Only the credentials for the first user login are captured. Single sign-on will enable PBA authentication to replicate for Windows authentication, so only one sign-on will be required for subsequent reboots. When using PBA, 2 reboots are required when first applying the policy to a device, one for encryption initialization and one for the PBA process. We'll use the same reboot settings here that we chose for encryption initialization in step 6. We'll stick with the default configuration for user lockouts and move to the final configuration screen, configuring hardware compatibility for PBA. The DMI configuration settings facilitate the transition from the Linux PBA to the Windows operating system. The predefined configurations are typically sufficient for most devices. If you have devices with unusual hardware configurations that are not compatible with the standard settings, resulting in the PBA not transitioning to the Windows operating system, you can modify the settings to add the correct configuration. The help provides instructions for doing this. In the summary page, you can review all your settings before completing the wizard. We'll leave the default to create a sandbox version of the policy and click Finish. With the policy created, we can now assign it to applicable devices, so we click the Assign Policy link in the Getting Started page. From this wizard, we can choose our devices, select the policy to assign, and enforce the policy immediately or wait to enforce it later. Enforcement adds the policy to applicable devices as a sandbox version upon ZENworks agent refresh. To initiate the encryption, we need to select the policy in the Policies page and publish the policy. But before we do that, we want to enable encryption audit events to help us track when encryption starts and completes on our devices. So we click Enable Encryption Events. This takes us to the Events Configuration page. From here, we go to Agent Events, select all the full disk encryption events, and complete the configuration. With the disk encryption policy created, assigned to applicable devices, and encryption auditing enabled, we're ready to publish the policy. As soon as the ZENworks agent is refreshed on applicable devices, the encryption will start. You can refresh devices by selecting them in the Devices page and running the Refresh Device quick task. Once encryption starts or completes on any devices, these can be viewed in the Audit and Messages pages. If we look at implementation of this policy on a device, we can see that during the second or PBA reboot on the agent device, the PBA screen is shown. This is when the user's credentials are captured from the previous login. After the reboot is complete, the user can then view the progress of disk encryption via the FDE About link in the ZENworks agent. Any subsequent reboots will require single sign-on authentication through the PBA screen in place of Windows Authentication. In this video, we've demonstrated how to create and assign a disk encryption policy to encrypt volumes on fixed disks, and also how to enable encryption audit events. For more information about using ZENworks security products, view other Getting Started videos or see the ZENworks documentation page. Thanks for watching.